Every single thing you do online, whether it's streaming a movie or just sending a quick email, it all boils down to solving this one really fundamental puzzle. It's like a tale of two addresses. So let's dive right in and figure this thing out.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
All right, so let's kick things off with a bit of a puzzle. Every single device you own, I'm talking your phone, your laptop, heck, even your smart fridge, it has this totally unique, permanent ID that's literally burned into its hardware at the factory. So, here's the big question. Why does the global internet, the whole shebang, pretty much just ignore it?
Well, the answer, it turns out, is that every single device on a network actually has two different names, kind of like a first name and a last name. So let's start with that first one. The name it was basically born with. So this permanent ID, it's called a MAC address. And a really good way to think about it is like a device's fingerprint, or maybe a serial number. It's completely unique across the entire planet. And here's the key. It never, ever changes. Its one and only job is to answer a single question. Who is the specific piece of hardware?
Okay, now, if you're just connecting a few devices in a small area, like on your home Wi-Fi network, this system is absolutely perfect. Your router has no problem keeping track of the handful of MAC addresses in your house and sending data to the right place. It's kind of like being in a small room where everybody just knows each other by their first name. Simple, right?
But what happens when we leave that cozy little room and try to connect to, say, a server on the complete opposite side of the planet? Yeah, that's where we smash right into a massive problem of scale. We're going to call it the Steve paradox, and it just perfectly shows the fatal flaw of trying to use these MAC addresses for everything.
Just think about it this way for a second. Your national ID number is unique to you, right? But there's no geographic logic to it. You can't just look at the number and go, oh yeah, that person's definitely from New York. It doesn't work that way. And a MAC address is exactly the same. It's just a random, unique number that gives you absolutely no clue about a device's location.
So just imagine if the whole internet actually tried to run on MAC addresses. To find just one device, you would literally have to broadcast a message, a shout, to every single connected device on the entire planet, asking, hey, is this your number? And then you just have to sit there and wait. It's not just inefficient, it's completely impossible.
So here's the bottom line. The MAC address system, it's great for your local network, for that small room we talked about, but it completely, totally falls apart on a global scale. It just fails. We absolutely needed a smarter way to do things.
And luckily for all of us, the early architects of the internet came up with that smarter system. And it is a brilliant solution, really, based on this one simple but incredibly powerful idea, the logic of location.
This is really the core difference right here. You see, a MAC address is flat. It's basically a random number that only tells you who a device is. But an IP address, that's hierarchical. It's structured on purpose like a mailing address to tell you where a device is. And that one simple difference, well, it changes absolutely everything.
The IP address is really the hero of our story here. Its power is all in its structure. That hierarchical design, that's the key. It's what solves that crazy global shout problem and lets the internet actually work on a massive scale. I mean, it's the one design choice that was so forward-thinking that it let this tiny academic project grow into the global network that we all use every single day.
Just think about how a letter gets to your house. The post office doesn't just shout your name out to the entire world, right? Of course not. It follows a hierarchy. First, it finds the right country, then the right state, then the city, and it keeps narrowing it down step by step until it gets to your specific house. While IP addresses do the exact same thing for our data on the internet.
All right, so just to recap, we have these two totally different address systems. We've got MAC for the local stuff and IP for the global stuff. Now, the cool thing is they aren't rivals fighting for control. Nope, they're partners, and the way they work together is kind of like a clever digital Russian doll.
Now, the fancy technical term for how they cooperate is encapsulation. I know it sounds super complicated, but honestly, all it really means is putting one package inside of another one. That's it. And this simple idea, it's the secret sauce for how your data gets from your little local network all the way out onto the massive global internet.
Okay, probably the easiest way to picture this whole thing is with a simple analogy. Think of your data as a letter, and it's addressed to a final destination, somewhere far away. But to actually get there, it has to be carried from one stop to the next by a local delivery truck.
So let's really break this analogy down. The letter, that's our actual data.
the IP datagram. It has the final, global destination address written right on it. Now, the delivery truck, that's the Ethernet frame. And the truck only cares about one thing, the very next local stop. It uses those MAC addresses to get there. But the most important part to remember is that the letter is always placed inside the truck.
So if there's one thing to remember, it's this. The global message rides inside the local delivery package. The truck, our Ethernet frame, only knows how to get to the very next router, and it uses those local MAC addresses to do it. And when it gets there, the letter, the IP datagram, is taken out, put into a brand new truck, and sent on its way to the next stop. It's this hop-by-hop journey.
Okay, so we know the global letter is inside the local truck. We get that part. But what information is actually written on that letter? What's guiding it all the way across the world? Let's go ahead and open up this little secret package and see what kind of instructions it's carrying inside.
And boom, there it is, right inside what's called the IP datagram's header. This is where we find the global directions for the entire trip. You've got the source IP address, which is where the journey started, and the destination IP address, its final goal. This is the exact information that all these giant internet routers use to pass your data along, from one to the next, all the way across the globe. So, there you have it. The mystery is pretty much solved. The internet actually works because of this really elegant partnership, right? A local name for the immediate next step journey and a global address for the final destination. We finally know how our data finds its way. But what other secrets is that little digital letter carrying? What other instructions are hiding in there? Well, we'll have to unwrap those in our next explainer.